My name is KylieFrame, and this is my pre-calculus project for 2019 called An Exponentially Unfair Deal. So an overview of the problem I will be looking at is I am one of three siblings. I have two brothers, one older and one younger. And in honor of our parents' 50th birthdays, they put $1,000 into a mutual fund account for each of us. But there was one catch. We couldn't take the money out of the account until we turned 50. At first I was excited, and then I realized, wait, is this fair? Or will my brothers be getting more than me? And if so, which one? So, when thinking about this problem, I realized that this was a problem of exponential growth. Another example of exponential growth is a tree growing. So, for example, if you took a tree that doubled in size every year, in the first year it might grow 10 inches, and then it would double, becoming 20, and then double again, becoming 40, and again, becoming 80, and then finally, in the fifth year, going to reach 160 inches. So, what's happening is, as you can see, as time goes on, the growth is increasing more and more and becoming more rapid. So, all of exponential growth can be explained within one formula, and this formula is y equals a times r to the xth. So to take a little bit of a closer look at that, the y in that will be the amount of growth, what like the height is in the tree problem, and the a is the base number you're starting with. The r is the rate at which something is growing or compounding, and then the x would be the number of times the compounding has occurred. So looking at that formula in the tree problem, you can see the a becomes the starting height, the r is the growth rate, and then the exponent, the 4, is the number of years passed or the number of times the compounding has occurred, and that gets us to 160. And if we go back, we see that when we did it manually, we got to that same 160 after 5 years. So what we have to ask ourselves now is, so how does this relate to the gift from my parents? And the answer to that question is that it's all about compounding. So the amount of time that our money compounds will have an effect on how much we have when we take it out when we turn 50. So to figure this out and to figure out if this deal is fair, we have to figure out what the number or the value for r is in my equation, or the compounding rate. So my parents put our money into an S&P index fund, which is designed to follow the stock market almost exactly. And the S&P average return was 11.83% per year over the past 33 years. So I decided that looking forward over the next 33 years, that was my best guess. So time to plug it into our equation. So the y for my equation will be the amount of money I get. The a will be the $1,000 that my parents put into my account at the beginning. And then the r is the 11.83% return that I expect to average every year. And the x will be 33, which is the number of years the funds will be invested, because I'm 17 and that is the number of years until I turn 50. So my equation becomes 1,000 times 1 plus 0.1183 to the 33rd, which gets me to $40,033. So in the tree example, R was 2 because it was doubling every year, and with the S&P account, the money will only increase 11.83% each year on average, so R becomes 1.183. Basically, I earn interest every year on the original investment plus the interest that I received in previous years. So what about my brothers? My little brother's equation would be different from mine because his x variable, the number of years, would be 37 as opposed to 33. So my brother's equation becomes 1,000 times 1 plus 0.1183 to the 37th, which equals $62,612, which as you can see is over $20,000 more than I will make. And not only that, but as you can see here, it's even more than my older brother will make. So this shows us how if all of our money is invested at the same time and it goes through this process of exponential growth at the same time, my brother, it hits when my brother turns 50, the amount of money that he will be getting is far less from the time my brother turns 50. And those last few years are crucial because as time goes on, the money becomes more and more very quickly. And that is displayed right here in these charts. As you can see, all of our money increases at the same rate, but as time goes on, the values begin to increase far and far more than they did at the very beginning. So at the very end, when my money gets cut off and my older brother's money gets cut off, is when you see the numbers jumping by thousands every single year. And the difference between when my older brother's money gets cut off to when my younger brother's money gets cut off in just those 6 years is is over $30,000. But if it was 5 years at the very beginning, it would be like $500. So that's a very good example of how exponential growth works and how by the end it's increasing, or after a long time, it's increasing very rapidly. So, how can we make this fair is my question. What can we do to alter this to make sure that my older brother and I are being treated equally as my younger brother? Because at this point, this gift they've given us is not fair. So there are two possible ways to do this, and one is to give me more money up front, more A, or to get a better return on my investment, which is a higher R. So option number one. First, what we need to do is solve for A. And when you solve for A in the given equation, you get $1,564. So if my mom and my dad put an extra $564 into my account, Carson and I would be all square when we each turn 50. For Andrew, the amount would would need to be almost double that at $1,955.94. And when we plug those numbers in, as you can see, when we all turn 50, it's gonna be about the same amount of money. But the difference is that Andrew's starting with the most, my older brother. I'm starting with the second most, and then Carson is starting with the least, so that it all balances out by the time we turn 50. So the second option would be to find a better mutual fund that would give me a better return. So now what we have to do is solve for R, which is the percent return that I would be getting in the stock every year. So when you solve for R, you end up with 13.35%. So 13.35% is what I would then plug into the R equation to make sure I'm getting back enough money that it would add up so that my siblings and I all end up with the same amount of money by the time we turn 50. So here on this graph, you can see again that although it will happen at different years, we will all end up with the same amount of money if we get the right amount. So if my mom and dad found an investment that would return 13.35% instead of 11.83%, Carson and I would be all square when we turn 50, and Andrew would have to get a return of 14.25% to get the same result. And so, as I explained before, you can see this in the graph below, as all the lines will eventually get to that same place. So, in conclusion, I'm not sure this is a battle I will win, but the lessons we learned about exponential growth and compound interest will give me what I need to put up a decent fight. It is also making me think twice about spending my money on things like clothes and food. If I put half of that money away until I was 50, think about how much money I would have. And these are the sources that I used to complete this project.